Hello students, today we're talking about heat load calculations and the amount of heat loss that escapes through different types of material. These heat load calculations should be taken into consideration when you are purchasing or sizing a furnace or an air conditioner for the home. So there are different standards that we use when we do heat load calculations based off what kind of material is used to make the walls, to make the ceiling, to make the floor, to make the windows. And then there is a coefficient of change. Are these numbers. So our first example is just one wall. This is just one wall that's facing the outside. So the other three walls of this structure of this room are not exposed to the outside elements, so they don't have any heat loss. So the heat load for the following side of the house for a 70-degree design temperature difference. The wall is wood frame with siding and 3.5 inches of insulation. So we have to find areas, and what I suggest is that you do the area of the window first. Window or door, depending on what you have. So this window is a 3x4 window. So we take the area of the window, 3x4. So it is 12 square feet. And then to find the heat load or the heat loss, we're going to take the area times the coefficient of change. So we take our 12, because that's the area, and the coefficient of change you have to look up on the chart. Now our window is a double pane window, and we're at a 70-degree temperature difference. So we're looking at this chart back here under windows, and we're in this column because we're a 70-degree temperature difference, and we are a double pane window. So our coefficient of change is going to be 70. We take this times 70. So 70 times 12 is 840 BTUs per hour, are being lost through that window. Now we have to actually do the wall itself. So to do the wall itself, we find the area of the whole wall, and we need to subtract out the area of the window. So the area of the wall is 12 by 8. Oops, by 8, which is 96 feet squared. And we have to subtract out the area of the window. So 96 minus 12 is 84 square feet for the wall itself. And again, to do the heat load, we're going to take that area and multiply it by the coefficient of change. So we're going to take 84 as our area, and we multiply it by, our wall is wood frame with siding and 3.5 inches of insulation. Wood frame with siding, 3.5 inches of insulation. So here's wood siding, 3.5 inches of insulation, we're still at a 70-degree temperature difference, so our coefficient is 5. $84 times 5 is 420 BTUs per hour, and BTU stands for British Thermal Unit. The total of those, 420 and 840, is the total heat loss for that room. Good. Nice, easy example to get us started. So we're going to go ahead and move to question number 2, or example number 2. You may need to draw a little picture. An easy way to draw a 3D picture is to draw like a rectangle or a square, and then draw another square up here and connect the corners. That'll help you draw a 3D picture. And it says, now mine doesn't look like it's drawn to scale, but it says it's 40 feet by 50 feet and 20 feet high. The warehouse was built on a concrete slab, so that has to deal with the floor, and has 6 inches of insulation in the wood frame for the walls, and at 9.5 inches of insulation for the ceiling. There's no windows in the building. The door's made just like the walls, so we don't have to worry about windows and doors in this one. But because all walls, ceilings, and the floor all have exposure to the outside elements, then we have to take all of those surfaces into consideration. So the for the walls, what we could do for the area of the walls is that we could find the area of all the individual pieces and then add them together. But you can also do the perimeter times the height. The perimeter times the height will get you the same thing. So the area of our walls, the perimeter would be around, let's say around the top or bottom of the warehouse. So we would go 40 by 50 plus 40 plus 50. And that's our perimeter. So 180 is our perimeter, times how high it is, how high the walls are. $3,600, and this would be square feet. Now to do the heat load for the walls, we take our area and we multiply it by our coefficient of change. Our area is 3,000, it's a big building, 3,600 square feet. And for the walls, it is 6 inches of insulation in the wood frame at a 75, it's a 75-degree temperature difference. So 6 inches of insulation would put me right here with the 75-degree temperature difference. Then our coefficient of change is 2.9 times 2.9, 10,440 BTUs are lost in that hour. just through the walls. So we have to talk about the ceiling, and the floor, right? So the ceiling is just this piece up on the top. So that would be 40 times 50, right, to get the area. Is 2,000 square feet. To do the heat load for the ceiling, you take your area times the coefficient of change. So it says it has 9.5 inches of insulation in the ceiling. If we go back to our table here, here's the ceiling, 9.5 inches of insulation. We're still at that 75-degree temperature difference, so our coefficient is 2.4. Make it very big. So the heat lost for the ceiling is 4,800 BTUs per hour. Our floor said that it was built on a concrete slab. So let's look at our floor. Oh, we're lucky. Floor on the ground, which is a concrete slab, says that there is no heat loss there. So we don't need to calculate anything for the floor, but we do need to add our other two heat losses together. 15,240 BTUs per hour. Would be our total heat loss for that whole warehouse. We're going to spend some more time doing these problems that are a little bit more detailed next week, and then the following week we'll end up having an end of the unit exam on these. But what I would like you to do in the meantime is go to the Google quiz, complete the Google quiz, make sure you hit submit, make sure you hit turn in. If you have any questions, please contact me. My email is cjones@ictc.edu. I hope you guys are having a great day and look forward to seeing you in class soon. All right? Thanks. Bye.